Welcome to your Additive Manufacturing News Review. Every 2 weeks, we bring you the latest breakthroughs, industry shifts, and cutting-edge innovations shaping the future of 3D printing. Today is Saturday, the 12th of April, 2025. Let's dive in. April is shaping up to be a defining month for additive manufacturing. From major market moves to national defense strategies, and from lunar missions to robotic aircraft assembly, AM is no longer just an emerging tech. It's the core of global industry transformation. The latest Wohlers Report confirms the trend. The additive manufacturing industry grew by 9.1% in 2024, reaching a global value of $21.8 billion. While machine sales slowed slightly, material producers saw some of the highest growth, especially in Asia, where expansion remains strong. That regional momentum is being matched by sector-specific surges. Take copper, for instance. The copper additive manufacturing market is projected to climb from $4.7 billion this year to $6.8 billion by 2030. This growth is fueled by rising demand in EV motor manufacturing, where conductivity and precision are critical. As design flexibility improves and development cycles shorten, manufacturers are unlocking new opportunities to tailor performance with speed and accuracy. We're also seeing real innovation in how we combine materials and methods. At Penn State, researchers achieved a major breakthrough in multi-metal 3D printing using powder bed fusion to bond stainless steel and bronze in a single structure. Their ability to print a complex gyroid form opens doors in biomedical, aerospace, and thermal applications, areas where hybrid functionality is becoming the new baseline. Another frontier is hybrid manufacturing, blending additive and traditional methods. Ricoh and ToffeeX showcased a cold plate for electric vehicles that combines 3D printed aluminium cores with die-cast housing and sheet metal bases. The result? Better cooling performance at lower cost, scalable for mass production. Digital tools are also accelerating this shift. Mivi, part of Masumi Group, launched AI-powered shape recognition software that can instantly generate machining quotes for complex parts with freeform curves. By automating geometry analysis, this technology cuts lead times and increases efficiency across prototyping and production. As AM innovation pushes forward, aerospace and defense sectors are leaning in hard. H2 Clipper has been awarded a patent for a robotic swarm manufacturing system. These AI-coordinated bots work in teams to autonomously assemble aircraft structures. No fixed lines, no rigid layouts, just adaptable mobile assembly with heavy lift capability and precision guidance. NASA is also pushing boundaries, bringing AM into its lunar programs. Through the Hunch initiative, high school students designed anchoring stakes to reduce dust on the moon's surface. These were printed by Elementum 3D using a high-performance aluminium alloy, demonstrating how education, space, and additive manufacturing are already intersecting. Closer to home, the UK's Ministry of Defence has released its first advanced manufacturing strategy, and additive manufacturing is front and centre. The plan focuses on decentralising production to reduce vulnerabilities, with an emphasis on speed, resilience, and rapid part access during critical scenarios. This is part of a broader trend, following the US Defense Innovation Unit's Blue Manufacturing Initiative, which connects commercial AM providers directly to the Department of Defense supply chain. Education and research are matching that ambition. The University of Wolverhampton is launching its new Centre of Excellence for Shaped Laser Additive Manufacturing. With deep roots in metal AM research and new capabilities in copper, silver, and titanium, the centre aims to generate spin-outs and support the UK's broader green innovation corridor. Meanwhile, the National Centre for Additive Manufacturing is celebrating 10 years of impact. From mobile production containers to advanced robot-based printing systems, NCAM is scaling up its contributions across both commercial and military spheres. In business, we've seen significant realignments. Nano Dimension finalized its acquisition of Desktop Metal in a $179 million deal. With new leadership in place, they're focusing on streamlining operations and creating long-term shareholder value. At the same time, Hexagon completed its acquisition of 3D Systems' Geomagic suite, integrating it into its broader manufacturing intelligence platform to boost scan-to-CAD workflows and metrology tools. Environmental gains are just as striking. Continuum Powders has recycled over 16,000 kilograms of Siemens Energy's nickel scrap into aerospace-grade powder, using a method that cuts carbon emissions by 99.7%. That's not just innovation. It's a blueprint for circular manufacturing. Finally, in the automotive world, additive manufacturing is racing ahead. The market is expected to surge to $16 billion by 2034 as lightweight components and custom EV parts become standard. At the same time, regional initiatives like Bavaria Makes in Germany are laying the foundation for industrial-scale AM adoption by aligning government, academia, and private industry. So, whether it's market growth, material breakthroughs, lunar tech, or robotic swarms, one thing is clear. Additive manufacturing isn't just evolving, it's defining the new industrial era. From Wolverhampton to the moon, from micro-cooling plates to national defense frameworks, this industry is building faster, smarter, and greener than ever before. That's a wrap on this week's biggest stories in additive manufacturing. Stay tuned, stay forward-looking, and above all, stay additive.